Hello guys, welcome back to my channel FRM Unplugged. We will be picking up again from where we left last time, where we discussed the time value of money, and we have already discussed the ways of interest calculation. One was simple interest, one is the interest calculation when we are compounding the interest either annually or once every 6 months or once in a quarter or once in a week. And we have also looked at how we calculate it in a compound when the interest is continuously compounded, which is it's compounded every fraction of time that we can imagine. So here we will take an extension of those scenarios in the sense that we will have to find out the current value of corpus that I need to have in hand if I were to receive X rupees in 5 years from now. And other scenario is if I want to receive X rupees and I have Y rupees today, then what is the interest rate that I can expect if I assume that the interest is compounded half yearly. So we will straight away get into the questions. So the first question here that we have is, if I have 1 crore in 10 years, which means today I want to have X amount. So if I have to, let's say I will retire in 10 years and I want 1 crore at the end of 10 years, what is the amount I need to invest today? And if we are assuming 8% annual compounding. So the answer is quite simple. X, let the amount be X into 1 plus 8 by 100 to the power 10, because we are compounding, right, is equal to 1 CR. Therefore, 1.08 to the power, so X is equal to 1 CR by 1.08 to the power 10. If we do the math, it comes to around 46 point something lakhs. So this was a fairly simple question. Next, we look at somewhat more complex question, right? Now, let's say a trader, okay? A trader has 100 million, let's say, take it as million in his savings account, and he wants to make it to 150 million, okay? Then, and we have been told that the period is 2 years, which means the trader wants the horizon of 2 years, and he expects that semi-annual compounding. So whatever interest he has achieved, he has received in the first 6 months, that gets added to the 100 million at the start of the second quarter, and so on for 4 quarters, right? So we have to find out what is the rate. So here obviously 100 into 1 plus, let's say, R is, we have to find out, and the period is 4, because so the normal one was 100 into 1 plus R to the power T, but when we have a number of periods, so the rate is divided by the number of periods, and we raise it to the power, not the year, but the number of periods. Had this been annual, we would have raised it to 2, but since this is semi-annual compounding, we will raise it to 4, is equal to 150. So this is how we can get R. Now, we can jolly well use our calculator to find out by the normal calculation. We can also use something called the cash. There is a cash flow. There are various aspects of cash flow that we can find out from our Texas Instrument calculator, right? So instead of having a standalone session on the calculator usage, I think this is better way of students to pick up the calculator skills, because we are doing a problem as well as taking the calculator in the example. So here in this case, what we will do, so I hope you all have the calculator. So it has something like this, and the last, there is a third row which has all the cash flow functions, N, I by Y, PV, PMT and FB. So what we will do here is, So before doing any problem on cash flow, we have to first clear out the memory, and by doing second and FB, which is, so for accessing any function which is above the keys, we will always use second. So in here we will, if we click on second and FB, this means we are clearing out any time value of money data which we have fed earlier. Now here n is the number of periods, right? So if we do n, right, so n will be 4, PV is equal to minus 100, because this negative term is important, because present value means 100 million I am giving it away. So it's a from the cash flow perspective, it is a drain, it is moving out from my system, hence minus. Sorry. And the final value is 150. I by Y, which is the actual rate, that is here is we have to find out, this is the one that we have to find out, and then we have the PMT, payment, interim payment. So there is no, we have not been told there is any interim payment in this particular problem, because whatever interest is coming, it is getting further added to the principal and getting further compounded. So payment amount is 0. So these are the 5 variables which are used to determine the cash flows. Okay, one is n, which is the period, number of periods. In this case it is 4. One is the final value, which is the amount I am getting. So 150 is positive because I will be receiving. What is the present value is minus 100 because I am giving. I by Y is the rate that I would be expecting for my investment. And since there are no interim interest payouts in my account, the interest, the payment, PMT, the full form is payment. So this is 0. Once we plug in these amounts, so if we put the n as 4, then if we put 4n 100 minus 100 is PV, 0 is PMT, 150 is FB, and then CPT I by Y. It is 21.33. So the way to solve this is, first we do the second, I'm just reiterating, second clear TVM, and then first type 4, then type n, then type, let's say, minus 100, and then press PV, then have 0, then press PMT, then 150, press FB, and then press compute, which is at the left top, and then press I by Y. So you will get 21.33. This is how you calculate these interest rates using the calculator. Now let us quickly look at another example on discount factors. Okay, so discount factors is concept is, I hope it's clear to everybody. So if discount factor of D of 1 means 0.85, this essentially means that if I were to get $1 at the end of 1 year, then I would be required to have 0.85 rupees as of today. So D of 1 is 0.85. This is the interpretation of discount factor. Now let us quickly solve, let us do a numerical on this, okay? So let us say there are 3 bonds, okay? Or maybe in one there are different tranches, however way you may take it, okay? So this is maturity, then this is the rates, and here is the price. Okay, so we are standing as on, so today we are standing, let us say, as on 1/1/2017, hypothetically assume. Now there is a tranche 1, this is getting matured on 30/6/2017, and the rate is 3.5%, and here the price is 99. So there is second tranche which is coming on 31/12/2017, and the rate is 4%, and the price is $100.16 and cents, and one is tranche 3. So here is 36/2018, and this is 5%, and this is 101.04. So all we are saying is the first tranche, so today is 1st January 2017, in 6 months from now the first tranche will mature, and this is the rate that I am assuming for this tranche. Similarly, the second is for 31/12, and so what we are expected to find out, we are expected to find out D of 0.5, D of 1, and D of 1.5 basis this bonds returns. Okay. So how we will do this is, now for any, like we did for any investment, like if 150 I am getting, then the present value is 100. How we got, the same way we will calculate, we will use the same concept here. So what we will see is, let's say 99 in 6 months time is equal to 99 in 6 months time is how much? So 6 months DF is equal, we have to find out, is equal to 101.75 into D of 0.5, right? Now this 101.75 where we are getting, I believe, I think since you guys may have done some practice, you would have known that 100 into 3.5%. See, when bonds have, let's say, makes payments every 6 months, then every 6 months it only pays the interest, and when it matures it pays the principal also. But in this case the bond is paying interest every 6 months, and the maturity is also in 6 months, so the entire amount will be paid on 30th June 2007. So if we do this, 3.5% of 100, right, by 2 is equal to what? 1.75. So at the end of 6 months, how much we are getting? We will be getting 101.75. So if the price today, if the today's price is 99 and I were to receive 101.75 on 6 months from now, so this is the discount factor that I need to. So if I multiply whatever I am receiving by the discount factor, I get today's value. So obviously discount factor will be always less than 1, because it can't be that 100 rupees is becoming 88. Obviously it can, but not for the purposes of these examples. So if we solve for D 0.5, we will get the final answer. Now for D of 1, how we will do? So for D of 1, just we can make this table, okay? We can make this table. D of 0.5, D of 1, and D of 1.5, right? So here we had received 101.75. This was for tranche 1. For tranche 2, again, what was the interest rate? 4%. 4%, so which means every 6 months it would be how much? 2. And it will be maturing what? On 31st December 2017. So here, so this is 31 December 2017. Here is 6 2018 and this is 36 2017, right? So here it doesn't receive anything, here it doesn't receive anything, this tranche 1. Tranche 2, here it receives how much? 2, because 4% per annum is 2 per year. And here it receives the balance, how much? 100 or 102? It receives 102 because 2 will be there plus the principal payment will be there. And does it receive anything here? No. Similarly for tranche 3, right? What was the interest rate? Interest rate was 5%, right? So how much it will be here? It will be 2.5 here. It will be 2.5 here. And here how much it will be? 102.5. Which is, see, let's write it this way so that it's more clearer. And just like the way we found out D of 0.5, the same way we can figure out the D of 1. So 200.50, right, is equal to 100.50 is equal to 2 into D of 0.5 plus 102 into D of 1. So with this we can figure out what is the final answer, right? Sorry, here whatever was the value here, no, let's check. 100.16 was the value, so we can put it here as 100.16. Sorry. And then we can find, so D of 0.5 we just found out there and we can just add it here. Similarly, we can find the D3. So this is how we find the discount factor. Discount factor is nothing but it's a discount rate. It is the rate that discounts the future value to the present value. That's all. So just like we did, we found out the interest rate, we found out the present value, the same process is used for valuing or finding out the current price of bonds. In the process, so see, bond is a very huge topic and we will discuss it separately, but for the purpose of using the concepts of time value of money, we will do a valuation of bond. So the essential thing is, if there is 1,000 face value bond, okay, and 5% is the coupon rate and 3% is yield, right? And it is semi-annual. We have to find out price of the bond is what, right? So what is the difference between this 5% and this 3%? The answer is, this bond in all probability, see, corporate bonds are issued never for 6 months, 1 year. They are usually issued for 7 years, 10 years, 15 years. And so when it was issued with coupon rate of 5%, which means the corporate issuer has promised the holder of the bond 5% per 6 months, which means every month that person, whoever is holding the bond, would receive how much? 2.5% of 1,000, which is 25 rupees every 6 months, right? Now, it is unlikely that any single person would be holding the bond throughout the life of the bond. He may have sold it in the secondary market and I would have bought it at the 8th year, where the remaining year to maturity is 2 years only. So here pending maturity period is, this is also given, let's say 2 years. So when I buy the bond at the end of 8th year, effectively I will get 3% only because I only have the balance 2 years. Had that person, or the one who sold it, had he held the bond till the entire life of the bond, he would have got 5%. But since I am holding it from the end of the 8th year, I will be only getting 3%. This is the yield, or this is the YTM. YTM is a term that we will use very frequently throughout the FRM courses. So here we have pending 2 years. So let us say 6 months, 12 months, 18 months and 24 months. So here we will get how much? 25. Here we will get 25. Here we will get 25. And here we will get 1025. So if we have to, again, in the terminology of the calculator, right, what is it that we have to find out? PV is the one we have to find out. What is the FV? FV is 1000. What is the payment? Payment is 25. What is N? N is 4. What is I by Y? I by Y is 1.5%. So I by Y, what is I by Y? I by Y is 1.5%. Therefore, if we plug these numbers, let us find out. Again the same way, second TVM. So 4 is N, then 1000 is FV, 1.5 is I by Y, and 25 is payment, and we have to compute the present value, which is minus 1068.70. You remember the last time when we found out the I by Y, we had inputted the PV with negative. So the answer will also come for PV as -1. So this bond, ideally this bond should be priced at 1068.70 if I were to buy it today, which is end of the 8th year. This is how we find out the value of the bond using the calculators, and this is how. So just see that, you know, even if we don't use the calculator, the logic works this way: that 25 divided by 1 plus 1.5% plus, I'm saying this is the total value of the bond. So calculator is one thing. If we go by the logic, then again the second tranche of 25 is coming when? In 12th month. So as of today, what we will do? 1 plus 1.5% to the power 2 plus 25 by 1 plus 1.5% to the power 3 plus 1025 by 1 plus 1.5% to the power 4. If you do the mathematically calculate this as well as this, both the answers should be same. Because what we are effectively doing is, if I am getting 25 after 6 months, what is its value today? 25 by 1 plus 1.5%, no? Just take it the other way, no? Had I had X rupees today, so X into 1 plus 1.5% is 25, no? We are just doing the reverse. So this is how we apply some of the concepts of time value of money. We will have to use this extensively during bond valuations, as well as in other derivatives, or in other when calculating VAR and all, we may need to use this. So this is a very, very fundamental and important concept that we have to be very clear on. And again, like, I am assuming that whoever is watching this has full idea on the theory of the bond values, what a bond is, how the compounding happens and everything. Because unless those things are clear, these numericals won't make sense. So with that, we kind of conclude today's session, and I think we have completed all the basic mathematics that we would be needed to cover the FRM topics. And from next video onwards, we will be resuming our numericals on paper 2 of FRM part 1. Thank you.